Hello students, welcome to your channel Parivartan Physics. See, many of you were requesting for online crash course for CET 2025, but I'm extremely sorry, we don't have the setup to make an online crash course. So I will not be able to conduct that online crash course. Right? So now offline crash course naವೇನು conduct ಮಾಡ್ತೀವಿ ಅದರ ಬಗ್ಗೆ ಒಂದು video upload ಮಾಡಿದ್ದೆ. So ಬಹಳಷ್ಟು ಜನ ಅಲ್ಲಿ request ಮಾಡ್ಕೊಂಡಿದ್ರಿ. So it is not possible for me for this year to make the online crash course. So instead of that, what I'm doing is I have planned a course called as Rapid Revision course for KCET 2025. So by this video, I'm starting this Rapid Revision course to help you all. So in this video, in this series of videos, I will be quickly revising all the formulas, concepts and shortcuts which are used for KCET MCQ solving, right? So videos it is not possible for me to solve the MCQs, but I will revise all the entire chapter in one video, one or two, maximum one chapter. In case there are more concepts, maximum in 2 videos I can do that. But on one, as much as possible, I will try to cover one chapter in one video, right? So in this video, we are going to complete this chapter, electric charges and fields, all the concepts and shortcuts in this video, right? So go through these concepts, remember these formulas, note down, make a list of these formulas, it will help you, and solve number of MCQs as well as KCET PYQs, which will surely help you in scoring good in your KCET exam. KCET PYQs also I have solved on every chapter, 10 years, 8 years, 7 years, 5 years, like this. Prati chapter ಮೇಲೆ solve ಮಾಡಿದ್ದೀನಿ. ಆ playlist ಕೂಡ ನಿಮಗೆ ಚಾನೆಲ್ ಒಳಗೆ ಸಿಗ್ತದೆ, ಅಥವಾ ಅದರ ಲಿಂಕ್ ಕೂಡ ನಾನು ಇಲ್ಲಿ ನಿಮಗೆ ಕೆಳಗಡೆ ಡಿಸ್ಕ್ರಿಪ್ಷನ್ ಒಳಗೆ ಕೊಟ್ಟಿರ್ತೀನಿ. You can go through that videos. ಆಮೇಲೆ if you want MCQs on each chapter, ಈಗ ಈ ಚಾಪ್ಟರ್ ಮೇಗಿನ ಕಾನ್ಸೆಪ್ಟ್ಸ್ ಅಂತ ನಾನು ಹೇಳಿರ್ತೀನಿ. If you want MCQs on each chapter, if you need, please put a comment so that I will make a PDF on most likely questions on these chapters and with solutions irtadri adu. In that PDF you will have question MCQs also and solutions also. If you want, I can provide a link there in the description box. You will get the PDF also, right? So ನೀವು ಲಿಂಕ್ ಮಾಡಿ ಆಗಿದ್ಮೇಲೆ ಒಂದಿನ ಆಗಿದ್ಮೇಲೆ ನೀವು ಡಿಸ್ಕ್ರಿಪ್ಷನ್ ಮತ್ತೆ ಚೆಕ್ ಮಾಡ್ರಿ, ನಿಮ್ಗಲ್ಲೇ ಅದು ಲಿಂಕ್ ಸಿಗ್ತದೆ. Okay, let us begin then without wasting the time. See, I have written all the things already. I will just go on explaining you. First thing, ಈಗ ನಮಗೆ types of methods of charging, right? Methods of charging ಒಳಗೆ induction, friction, conduction ಅಂತ ನಮಗೆ 3 methods ಅದಾವ. In that friction, so whenever a glass rod is rubbed, when 2 bodies are rubbed against each other, one body will lose the electron, it will become positive, another body will gain the electron, it will become negative. One very popular example for that is glass rod when rubbed with a silk cloth. Whenever a glass rod is rubbed with a silk cloth, at that time what happens? Glass rod will lose the electrons. Glass rod rubbed with a silk cloth, glass rod will lose the electron and it will become positive. Silk cloth will gain the electron and it will become negative, right? After that, quantization formula, whenever number of charges are asked to calculate, ನಿಮಗೆ ಯಾವಾಗ number of charges in calculate ಮಾಡಂತ ಕೇಳ್ತಾರೆ, at that time go for this formula, Q is equal to plus or minus n into E. If electrons are given to a body, it will become negatively charged, so take minus n into E. If electrons are removed from a body, then it will become positively charged, take plus n into E, right? N is number of electrons, right? So Q is the charge on the body, E is the charge of an electron. In 1 coulomb of charge, how many number of electrons will be there? We can calculate that by this only. Here you can take Q is equal to 1 and N, E antandre ನೀವು 1.6 into 10 to the power minus 19 ತಗೊಂತೀರಿ. So take N is equal to 1 divided by this much, you will get this. 6.25 into 10 raised to 18 number of electrons will be present in 1 coulomb of charge. Next, see, electric force and gravitational force. ಈಗ ನಮಗೆ ಏನು most fundamental forces ಅದಾವ nature ಒಳಗೆ, electric force, gravitational force and nuclear force. Weakest force is gravitational force, strongest force is nuclear force, right? Electric ಮತ್ತು gravitational force, if you take 2 charges or 2 particles, the ratio of electric force and gravitational force will be equal to 10 raised to 36. See, if 2 charges are separated by a certain distance in air, let me say this is Q1 and this is Q2, these both are separated by distance r in air. If they are separated by distance r in air, then the force between the 2 charges is 1 by 4 pi epsilon Q1 into Q2 by r square, which is Coulomb's force. And if you substitute a medium here, instead of air, if you substitute a medium whose dielectric constant is K or epsilon r, then it will be 1 by 4 pi epsilon into epsilon r. So this one term ನಮಗೆ extra ಬರ್ತದೆ, Q1 into Q2 divided by r square. Okay, so what is that relative permittivity or dielectric constant? Relative permittivity or dielectric constant is force in air divided by force in medium, or it can also be written as permittivity of the medium divided by absolute permittivity. ಈ ತರ ನಾವು ಬರಿಬಹುದು. That is dielectric constant or relative permittivity. Next, dielectric constant or relative permittivity for metal is infinity. So ಈಗ suppose ನೀವು ಈ ಎರಡು ಚಾರ್ಜಸ್ ನಡುವೆ if you insert a metal, ನೀವು ಇಲ್ಲಿ metal ಹಾಕೊಂಡ್ರಿ ಅಂತಂದ್ರೆ force between the 2 charges will become 0, right? Because the dielectric constant of forces dielectric constant of the metal is infinity. That's why the force between the two charges will become infinite. In next note, if the distance between the two charges, let me say this is q1, and this is q2. The distance between the two charges is filled up by two different dielectric medium. This is the first dielectric medium whose dielectric constant is k1, and the distance covered by this is r1. And this is the second dielectric medium whose dielectric constant is k2, and the distance of this is r2, right? If there are two dielectric mediums in between the two charges, then the force between them is calculated by 1 by 4 pi epsilon q1 divided by root k1 into r1 plus k2 into r2 whole square. If there is three dielectric mediums, k1, k2, k3, here you have to add one more term called as plus root k3 into r3 whole square. So like this, you have to calculate the force when multiple dielectric mediums are substituted in between the charges. Relation between electric field and force, E is equal to F divided by Q, force divided by charge, right? Okay, we'll go to the next concept then. See, here a simple pendulum, a charged pendulum is hanged. Whenever a horizontal electric field is applied, that charged pendulum will get displaced from this point to this point. So it will remain in equilibrium here. Three forces will be acting on it. One is force due to the electric field, that is F is equal to Q into E in horizontal direction. Weight W is equal to mg in downward direction. Tension in this direction. This case nimage questions in either to calculate this angle theta or to calculate the tension acting in the thread. Right? So, external electric field, here we have taken two bobs. There is no external electric field. Now external electric field apply madilla. Since both the metallic spheres are having same charge, there will be a repulsive force. One repulsive force in this direction, repulsive force on this in this direction. So here repulsive force will be 1 by 4 pi epsilon q square divided by r square. R is the distance between them. Charge of both the spheres will be same. That's why it is q square divided by r. Force q into E, force 1 by 4 pi epsilon q square divided by r square. Again same forces, electric force, weight, tension, electric force, weight, tension, right? Only the formula of force has got changed. So in two cases angle with vertical calculate madanta keltare. To calculate the angle with vertical, you use the formula tan theta is equal to F divided by W, and to calculate the tension, you have the formula T is equal to root of F square plus W square. This is the tension. In standard results, vector the standard results right? We know very well, if two vectors P and Q are acting at an angle theta, then the resultant will be R is equal to root of P square plus Q square plus 2PQ cos theta. If P and Q are equal, under F mat F, two equal vectors are acting at an angle 90 degree, then the resultant will be root 2F. F and F at 90 degree, resultant is root 2F. If two equal vectors are acting at an angle 60 degree, root 3F. 120 degree F. Correct? So equal vectors are there. Angle 90 degree between them, root 2F. Angle 60 between them, root 3F. Angle 120 in between them, F. And this resultant will divide this angle in two equal halves. 45 degree on that side and 45 degree on this side. 60 degree on this side and 60 degree on this side. Right? 30 degree on this side and 30 degree on this side. It's 60 degree angle. 120 either is 60, it's 60. Right? It will divide the angle between the two vectors equally. Okay, these are the standard results of vector you have to remember. Okay, next we'll go for electric field. E is equal to F divided by Q. We already know this. Electric field due to a point charge 1 by 4 pi epsilon Q divided by R square, where R is the distance from that charge. Electric field due to a charged ring. Charged ring antadre namage itara irtatri. This is the charged ring, right? So ee charged ring the center dinda x distance olaga navu enadru one point tagondre. If we take a point at a distance x and the radius of this charged ring is R, then the electric field at this point will be 1 by 4 pi epsilon qx divided by r square plus x square whole raised to 3 by 2. At the center of the ring, electric field will be 0. Right? At the center of the ring, electric field will be 0. Charged arc means it is not the full ring. It is like this. This is the charged arc. And if you want to find out the electric field at the center of this charged arc, electric field if the angle between the lines joining the ends of the conductor is theta, then you use this formula 2k lambda divided by r sin theta by 2, where k is 1 by 4 pi epsilon or 9 into 10 raised to 9. Right? This is the electric field of a charged arc. Next, axial point dipole. See, electric field at an axial point of the dipole. We know very well, dipole antandre idu nimage gottirli. This is minus q, this is plus q. Dipole moment will always be from negative to positive direction. Negative to positive direction, distances are always measured from center of the dipole. And the length of the dipole axis is taken as 2a. Length of the dipole axis. Here will be the axial point. Here will be the equatorial point. Illi namage equatorial point irtadre. Illi namage axial point irtadre. This is axial point and this is equatorial point. So at axial point, electric field is EA is equal to 1 by 4 pi epsilon 2p upon r cube. So electric field is inversely proportional to the cube of the distance. At equatorial point, it is 1 by 4 pi epsilon naught P divided by R cube. Here also electric field is inversely proportional to R cube. So the relation between axial field and equatorial field is, axial field is 2 times of equatorial field, 2 times right? So more field is here. So what will be the resultant field direction at this point? At this point, the resultant field will be in this direction. It means along the direction of P it will be. At equatorial point, the resultant electric field will be anti-parallel to the dipole moment. So opposite direction. That's why here you can mention minus also. Minus because it will be in opposite direction of the dipole moment. Right? Okay, we'll go for the next thing then. See, at any general point of the dipole, this is the axial point, this is the equatorial point. If I take any point here which is neither axial nor equatorial, then the line joining from the center of the dipole to this point will subtend an angle theta with respect to the dipole. A dipole jotege theta angle subtend ಮಾಡ್ತದ್ರೆ and the distance is r. Then electric field at this point will be 1 by 4 pi epsilon naught P by R cube root of 3 cos square theta plus 1. This formula same adri 1 by 4 pi epsilon naught P by R cube. This equatorial electric field. This one multiply root of 3 cos square theta plus 1. Right? Next note. Motion of charged particle in uniform electric field. See, here we are having a uniform electric field E right side direction. If you place a positive charge in the electric field, it will experience a force in the direction of electric field and it will start moving in a straight line. If you place a negative charge in the electric field, it will experience a force in the opposite direction of electric field. It will start moving in a straight line. Force will be Q into E, Q into E. So if force is equal to Q into E, then according to Newton's second law, acceleration is equal to force by M, force is Q into E divided by M. So acceleration is QE divided by M. So the move ಆಗ್ತಿರುವಂತ ನೋಡ್ರಿ charged particle ನೀವು electric field ಒಳಗೆ ಇಟ್ಟಿದ ಮೇಲೆ it will experience the force and it will start moving. When it starts moving in the straight line, it will be having acceleration, velocity, displacement, kinetic energy, momentum, all these things will be there. So first year mechanics in formulas iddu our formulas ನೀವು ಇಲ್ಲಿ apply ಮಾಡಬಹುದು. Force is Q into E, acceleration is QE divided by M. See, V is equal to U plus AT. Initial velocity will be 0, so A into T. A is how much? QE by M. So QET divided by M. So the velocity of that particle will be QE into T divided by M. Displacement, ut plus half at square. Initial velocity will be 0, this term becomes 0, half at square. A is QE by M. So half QE divided by M into T square. Momentum, M into V. V is QET by M. So M into V ಅಂತಂದ್ರೆ M cancel ಆಗ್ತದ್ರೆ QET. This will be the momentum. Kinetic energy, half mv square, right? So V square, V is here, you square it and substitute, you will get kinetic energy equal to Q square E square T square divided by 2M. Work done, force into displacement. So force illade, displacement illade, substitute ಮಾಡಿ calculate ಮಾಡ್ಕೊಂಡ್ರೆ QES, you will get this is the work done, right? These are the formulas of acceleration, force, velocity, displacement, momentum, kinetic energy and work done whenever a charged particle is moving in uniform electric field. Okay, let us go to the next concept then. See, electric field due to infinite long charged wire, E is equal to lambda by 2 pi epsilon naught R. What is R? R is the distance from that infinite wire. So, this wire din now a point in ಎಷ್ಟು ದೂರ ತಗೊಂಡಿರ್ತೀವಿ, that is called R. So, lambda by 2 pi epsilon naught. What is lambda? Lambda is linear charge density, charge divided by length. Its unit is coulomb per meter. Right? Infinite plane sheet. Electric field due to infinite plane charged sheet will be sigma by 2 epsilon naught. What is sigma? Sigma is Q divided by area, whose unit will be coulomb per meter square. Right? So, what is sigma? Sigma is charge density. Right? Okay. See, electric field due to the straight infinite long charged wire is dependent on the distance. It is dependent on distance. As you go far from the wire, the electric field goes on reducing because field is inversely proportional to distance. But electric field due to infinite charged plane sheet is not dependent on the distance. Wherever you take the point, the electric field will be same due to that plane sheet. Okay, next, electric field due to the charged sphere. ಇಲ್ಲಿ ನಾವು 3 point ತಗೋತೀವಿ. Outside point that is A, surface point that is B, and inside point that is C. Right? Electric field outside the sphere will be same as that of point charge. ಅಂದ್ರೆ ನೀವು ಈ charged sphere ನ ಒಂದು point charge ಅಂತ ತಗೋಬೇಕು, which is at the center. ಒಂದು charged point ಅಂತ ತಗೊಂಡು charged sphere ನ ಒಂದು point charge ಅಂತ ತಗೋಬೇಕು. That point charge is at the center of the sphere. So electric field outside the sphere will be 1 by 4 pi epsilon naught Q divided by small r square. Electric field on the surface of the sphere will be 1 by 4 pi epsilon naught Q divided by radius square, capital R square, because here small r will be equal to capital R. And electric field inside the sphere will be 0 because there are no charges inside the conductor. Charges always reside on the surface of conductor. They will not be present inside the conductor. That's why electric field inside the sphere will be 0. Okay, so here these are the charge densities, lambda, gamma, sigma and gamma. linear charge density charge by length, surface charge density charge by area, volume charge density charge divided by volume. Depending on the body, you have to take this charge densities. Okay, we'll go for the next concept now. See, electric field at the center of regular polygon. Regular polygon antandre ena triangle, square, pentagon, hexagon, octagon. These are the regular polygons. So our regular polygons are yella sides equal irtave. Angles will angle at every vertex will be same 60 60 60 90 90 90 like this, right? So all the length of all the sides will be same, angles will be same. And if similar charge is placed at every vertex of that regular polygon, triangle ಮೂರು vertex ಮೇಲೆ q, square ಮೂರು ನಾಲ್ಕು vertex ಮೇಲೆ q, pentagon 5 vertex ಮೇಲೆ q. Like this, if you place the similar charges at every corner of that regular polygon, electric field at the center of the regular polygon will be zero. When similar charge is placed at the vertex of each vertex of the regular polygon. In next nodri, if igilina square ತಗೊಂಡಿದ್ದೀನಿ, only 3 charges are placed at the 3 corners of the square. There is no charge in the 4th corner. That's why in this case, electric field of this charge and electric field of this charge will get cancelled. But each charge the electric field cancel agangilla, it will remain there. So electric field will not be zero if there is no electric charge at any one of the vertex. ಇಲ್ಲಿ ಏನಾಗ್ತದ್ರಿ ನೋಡ್ರಿ, ಈ ಚಾರ್ಜ್ ದ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ನಮ್ಗೆ ಈ ಕಡೆ ಇರ್ತದ್ರಿ, ರೈಟ್? ಈ ಚಾರ್ಜ್ ದ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ನಮ್ಗೆ ಈ ಕಡೆ ಇರ್ತದ್ರಿ, ಇಟ್ ವಿಲ್ ಬಿ ಇನ್ ದಿಸ್ ಡೈರೆಕ್ಷನ್. ಈ ಚಾರ್ಜ್ ದ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಈ ಕಡೆ ಇರ್ತದ್ರಿ, ಇಟ್ ವಿಲ್ ಬಿ ಇನ್ ದಿಸ್ ಡೈರೆಕ್ಷನ್. ಈ ಚಾರ್ಜ್ ದ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ನಮಗೆ ಈ ಕಡೆ ಇರ್ತದ್ರಿ. So these electric fields will get cancelled and hence net electric field will become zero, right? So ille ee charge the field cancel aglike namaga mattondu charge illa, so there will be one electric field remaining. Ella cases olaga hangare, if all vertexes are including one charge is present, then net field at the center will be zero, otherwise it will be non-zero. Okay, next we'll go for one more concept now called as neutral point. See, neutral point andre where net electric field is zero, right? Igille na en madidine, I have taken two like charges, plus q1 plus q2. I have taken two like charges. If I take a point in between the charges, ee charges middle dolaga na illadru ಒಂದು point ತಗೊಂಡ್ರೆ, if I take a point in between the charges, then at this point, due to plus q1 charge, electric field will be in this direction, positive on the radial outwards. Due to plus q2 charge, electric field will be in this direction, positive in the radial outwards. Here electric fields are opposite in direction, so net electric field will be equal to E1 minus E2. And if E1 and E2 are equal in magnitude, then the resultant electric field will be zero. So this is said to be neutral point. ಇದಕ್ಕೆ neutral point ಅಥವಾ null point ಅಂತ ಕರೀತಾರೆ. Net electric field is zero. So net electric field zero ನಿಮಗೆ ಸಿಗಬೇಕಾದ್ರೆ, at that point there has to be two equal and opposite electric fields. ಆ ಪಾಯಿಂಟ್ ಒಳಗೆ ಎರಡು equal and opposite electric fields ಇರಬೇಕು. Same direction ತೆಗಿದ್ರೆ ನಡೆಯಂಗಿಲ್ಲ, opposite direction ತೆಗಿರಬೇಕು, then only you will get resultant zero. See, if I take a point outside this system, ಈ system ಬಿಟ್ಟು ಹೊರಗಡೆ point ನ ತಗೊಂಡ್ರೆ, here electric field ಈ point ಆಗಲಿ ಅಥವಾ ಈ point ಆಗಲಿ, you take both the points. At these points, the electric fields due to Q1 and Q2 will be in same directions. They will get added. So you cannot get neutral point outside the system when there are like charges. Like charges iddaga, you will not get the neutral point outside the system. You will get the neutral point in between the two charges inside the system, right? Other suppose unlike charges iddu anta itgori, plus Q1 minus Q2. Unlike charges idre, you will get neutral point outside the system. Yakandre electric fields will be in opposite direction outside the system. In between the two charges, electric field same direction dagiರ್ತವ್ರಿ, so they will get added. You will not get zero. So in both the cases, ಎರಡು ಕೇಸ್ ಒಳಗ್ರಿ, like charges ಅಥವಾ unlike charges ಒಳಗೆ ನಿಮಗೆ ಏನು ಕೇಳ್ತಾರೆ ಅಂತಂದ್ರೆ, you will have to find the distance of this neutral point. In neutral point the distance ನೀವು find ಮಾಡಬೇಕು, x ಅಂತ ತಗೊಳ್ರಿ. You have to find out the distance of this neutral point, x, right? So from Q1 we have to find out x ಅಂತ ನಾ ಇಲ್ಲಿ ಬರ್ತೀನಿ, neutral point. ಅಥವಾ ಕ್ವೆಶ್ಚನ್ ನಿಮಗೆ ಹಿಂಗೆ ಕೇಳಬಹುದು, ಫೈಂಡ್ ದ ಪಾಯಿಂಟ್ ಅಟ್ ವಿಚ್ ದ ನೆಟ್ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಇಸ್ ಝೀರೋ ಅಥವಾ ನ್ಯೂಟ್ರಲ್ ಪಾಯಿಂಟ್ ಅಂತ ಕೇಳಬಹುದು. ಆರ್ ದೇ ಮೇ ಆಸ್ಕ್ ಯು ಲೈಕ್ ದಿಸ್ ಆಲ್ಸೋ, ದೇರ್ ಇಸ್ ಅ ಸಿಸ್ಟಮ್ ಆಫ್ ಟೂ ಚಾರ್ಜಸ್ ವೇರ್ ದ ಥರ್ಡ್ ಚಾರ್ಜ್ ಹ್ಯಾಸ್ ಟು ಬಿ ಪ್ಲೇಸ್ಡ್ ಸೊ ದಟ್ ಇಟ್ ವಿಲ್ ಎಕ್ಸ್ಪೀರಿಯನ್ಸ್ zero force. ಮೂರನೇ ಚಾರ್ಜ್ ನೀವು ಯಾವ ಪಾಯಿಂಟ್ ಒಳಗೆ ಇಟ್ಕೊಂಡ್ರೆ zero force ಅನ್ನು ಎಕ್ಸ್ಪೀರಿಯನ್ಸ್ ಮಾಡ್ತದೆ. ಸೊ ಥರ್ಡ್ ಚಾರ್ಜ್ ಹ್ಯಾಸ್ ಟು ಬಿ ಪ್ಲೇಸ್ಡ್ ಅಟ್ ದ ನ್ಯೂಟ್ರಲ್ ಪಾಯಿಂಟ್, ದೆನ್ ಓನ್ಲಿ ಇಟ್ ವಿಲ್ ಎಕ್ಸ್ಪೀರಿಯನ್ಸ್ zero force. ಸೊ ಯು ಹ್ಯಾವ್ ಟು ಫೈಂಡ್ ಔಟ್ ದ ಡಿಸ್ಟೆನ್ಸ್ ಆಫ್ ದಟ್ ನ್ಯೂಟ್ರಲ್ ಪಾಯಿಂಟ್. ಸೊ ಟು ಫೈಂಡ್ ಔಟ್ ದ ಡಿಸ್ಟೆನ್ಸ್ ಆಫ್ ದಟ್ ನ್ಯೂಟ್ರಲ್ ಪಾಯಿಂಟ್ ವಿ ಹ್ಯಾವ್ ಅ ಶಾರ್ಟ್ಕಟ್ ಫಾರ್ಮುಲಾ ಹಿಯರ್, distance of null point from smaller charge. ಅಂದ್ರೆ ನೋಡ್ರಿ, ಇಲ್ಲಿ Q1 Q2 ಅಂತ ಏನು ಎರಡು ಚಾರ್ಜ್ ಅದಾವ, ಇದರೊಳಗೆ ಸ್ಮಾಲರ್ ಚಾರ್ಜ್ Q1 ಅಂತ ಇಟ್ಕೊಂಡ್ರೆ, from smaller charge this formula will give you the distance. ಆ null point ದ ಡಿಸ್ಟೆನ್ಸ್ ನಿಮಗೆ ಈ ಫಾರ್ಮುಲಾದಿಂದ ಎಲ್ಲಿಂದ ಸಿಗ್ತದಪ್ಪ ಅಂದ್ರೆ ಸ್ಮಾಲರ್ ಚಾರ್ಜ್ ಇಂದ ಸಿಗ್ತದ್ರಿ. R divided by root of Q2 by Q1 plus or minus 1. ಈ ಫಾರ್ಮುಲಾ ಒಳಗೆ Q2 ಅಂದ್ರೆ ಗ್ರೇಟರ್ ಚಾರ್ಜ್, Q1 ಅಂದ್ರೆ ಸ್ಮಾಲರ್ ಚಾರ್ಜ್. ಸೊ ನಿಮಗೆ ಏನ್ ಚಾರ್ಜಸ್ ಅಲ್ಲಿ ಕೊಟ್ಟಿರ್ತಾರೆ ಕ್ವೆಶ್ಚನ್ ಒಳಗೆ, ಅದ್ರ ಗ್ರೇಟರ್ ಚಾರ್ಜ್ ಯಾವ್ದದ ಅದನ್ನ Q2 ಅಂತ ತಗೊಳ್ರಿ, ಸ್ಮಾಲರ್ ಚಾರ್ಜ್ ಏನದ ಅದನ್ನ Q1 ಅಂತ ತಗೊಳ್ರಿ. ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ Q2 ಹಿಯರ್, Q1 ಹಿಯರ್, ಅಂಡ್ ಪ್ಲಸ್ ಚಾರ್ಜ್ ಫಾರ್ ಲೈಕ್ ಚಾರ್ಜಸ್. ಎರಡು ಲೈಕ್ ಚಾರ್ಜಸ್ ಇದ್ರೆ ಪ್ಲಸ್ ತಗೊಳ್ರಿ, ಇಲ್ಲೇ ಪ್ಲಸ್ ಆರ್ ಮೈನಸ್ ಅದ. ಅನ್ಲೈಕ್ ಚಾರ್ಜಸ್ ಇದ್ರೆ ಮೈನಸ್ ತಗೊಳ್ರಿ. right? So this formula will give you the distance from smaller charge. q1 ಸಣ್ಣದಿತ್ತು q2 ದೊಡ್ಡದಿತ್ತು ಅಂದ್ರೆ ಈ ಡಿಸ್ಟೆನ್ಸ್ ನಿಮಗೆ ಸಿಗ್ತದ್ರಿ ಆ ಫಾರ್ಮುಲಾ ಯೂಸ್ ಮಾಡಿದ್ಮೇಲೆ. ಸಪೋಸ್ ನಿಮಗೆ ಕ್ವೆಶ್ಚನ್ ಒಳಗೆ q2 ದಿಂದ ಡಿಸ್ಟೆನ್ಸ್ ಕೇಳಿದ್ರಪ್ಪ ಅಂತಂದ್ರೆ ನೋಡ್ರಿ ಎರಡು ಚಾರ್ಜಸ್ ನಡುವಿನ ಡಿಸ್ಟೆನ್ಸ್ ನಿಮಗೆ ಕೊಟ್ಟಿರ್ತಾರೆ, ಈ ಫಾರ್ಮುಲಾ ಯೂಸ್ ಮಾಡಿದ್ರೆ ನಿಮಗೆ x ಸಿಗ್ತದೆ. ಸೊ r minus x ಮಾಡ್ಕೊಂಡ್ರೆ you will get this distance you will get r minus x. So from bigger charge you will get this distance, right? So this is the formula to find out the neutral point or the null point. Okay, we'll go for the next concept then. See, torque acting on an electric dipole which is placed in uniform electric field. Uniform electric field ಒಳಗೆ ಪ್ಲೇಸ್ ಮಾಡಿದಂತ ಡೈಪೋಲ್ ಮೇಲೆ ಎಷ್ಟು ಟಾರ್ಕ್ ಆಕ್ಟ್ ಆಗ್ತದೆ, PE sin theta. ವೆಕ್ಟರ್ ಫಾರ್ಮ್ ಒಳಗೆ P cross E, cross product will be PE sin theta. When torque is maximum, when the dipole is placed perpendicular to the electric field, torque will be maximum, theta equal to 90 degree. When dipole is placed parallel to the electric field, theta equal to 0 degree, torque will be minimum, right? See, if theta is equal to 0 degree, dipole is in stable equilibrium. Stable equilibrium ಅಂತಂದ್ರೆ ಅದನ್ನ ಡಿಸ್ಟರ್ಬ್ ಮಾಡಿದ್ರು ಕೂಡ ವಾಪಸ್ ಅದರ ಒರಿಜಿನಲ್ ಸ್ಟೇಟ್ ಗೆ ಬರ್ತದೆ. ಅನ್ಸ್ಟೇಬಲ್ equilibrium ಅಂದ್ರೆ ಅದನ್ನ ಡಿಸ್ಟರ್ಬ್ ಮಾಡಿದ ಮೇಲೆ it will not come back to its original state, right? So if theta is equal to 0 degree, the dipole will be in stable equilibrium. If theta is equal to 180 degree, then the dipole will be in unstable equilibrium, correct? Okay, next order. If the dipole is placed in uniform electric field, dipole uniform electric field ಒಳಗಿದ್ರೆ net force acting on the dipole will be 0, but net torque will not be 0. ಅಂದ್ರೆ ಅಲ್ಲಿ ಫೋರ್ಸ್ ಆಕ್ಟ್ ಆಗ್ತಿರಂಗಿಲ್ಲ, ಟಾರ್ಕ್ ಮಾತ್ರ ಆಕ್ಟ್ ಆಗ್ತಿರ್ತದೆ. So torque is responsible for rotational motion, hence dipole will execute only rotational motion. It will exhibit only rotational motion, no linear motion. ಅಂದ್ರೆ dipole ಒಂದೇ ಜಾಗದಾಗ rotate ಆಕೋತ ನಿಲ್ತದ್ರಿ, it will not move from one point to another point. If it is placed in non-uniform electric field, other dipole ಏನಾದರೂ suppose non-uniform electric field ಒಳಗೆ ಇಟ್ಕೊಂಡ್ರೆ, their net force will also be acting, net force 0 ಇರಂಗಿಲ್ಲ, torque will also be acting, torque 0 ಇರಂಗಿಲ್ಲ, ಎರಡು ಆಕ್ಟ್ ಆಗ್ತಿರ್ತಾವೆ. Net force is also acting, net torque is also acting. Due to net force, it has to move from one point to another point because force is responsible for rectilinear motion. Due to torque, it has to rotate because torque is responsible for rotational motion. So it will rotate as well as it will move from one point to another point, right? So illé nimage rotational motion plus linear motion eradu kaanistave, where in non-uniform electric field, uniform electric field ಒಳಗೆ ನಿಮಗೆ ಬರೀ rotational motion, rotate ಮಾತ್ರ ಆಗ್ತದ್ರಿ, it will not get displaced from one point to another point, right? Okay, we'll go for the next concept now. See, work done in rotating the dipole. Work done in rotating the dipole is given by W is equal to PE cos theta 1 minus cos theta 2. Okay, what is theta 1 and theta 2? For example, ಈಗ ತಿಳ್ಕೊರಿ, if this is the uniform electric field, ಇದು ನಮಗೆ uniform electric field ಇದೆ. Uniform electric field. If initially the dipole is placed parallel to the field, ಈಗ ನಮಗೆ ಇದು dipole ಇದೆ, ನಮಗೆ initially dipole ನ parallel ಆಗಿ ಇಟ್ಕೊಂಡಿದ್ದಾರೆ, electric field parallel ಆಗಿ ಇಟ್ಕೊಂಡಿದ್ದಾರೆ. So theta 1 is equal to 0 degree ಅಂತ ತಗೋಬೇಕು. And if it is rotated, see, if it is rotated at an angle 60 degree to the electric field, then theta 2 has to be taken 60 degree. Suppose ಅದು ಇನಿಷಿಯಲಿ 60 ಡಿಗ್ರಿ ಒಳಗೆ ಇಟ್ಕೊಂಡಿದ್ರು, ಆಮೇಲೆ ಅದನ್ನ 80 ಡಿಗ್ರಿಗೆ ರೋಟೇಟ್ ಮಾಡ್ಕೊಂಡಿದ್ರಪ್ಪ ಅಂತಂದ್ರೆ theta 1 ನೀವು 60 ಡಿಗ್ರಿ ತಗೋಬೇಕು, theta 2 ನೀವು 80 ಡಿಗ್ರಿ ತಗೋಬೇಕು. Like this the angles we have to take and we have to substitute them here, then we will get the work done. Okay, potential energy of an electric dipole placed in a uniform electric field will be equal to minus PE cos theta. U is equal to minus PE cos theta. That is potential energy. Okay, at different angles, work done, torque ಮತ್ತು potential energy ಅವತರದ ವ್ಯಾಲ್ಯೂ ಏನಾಗ್ತದೆ, ಯಾವ್ದು ಎಲ್ಲಿ ಮ್ಯಾಕ್ಸಿಮಮ್ ಅದ ಅದನ್ನ ನೆನ್ಪಿಟ್ಕೊಳ್ಳಿಕ್ಕೆ ಅಂತೇಳಿ ನಾ ಇಲ್ಲಿ ಒಂದು ಡಯಾಗ್ರಾಮ್ ಹಾಕಿದ್ದೀನಿ. ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್, ಯೂನಿಫಾರ್ಮ್ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ is in this direction. So theta is equal to 0 degree. When dipole is placed parallel, theta is equal to 90 degree. When dipole is placed perpendicular, theta is equal to 180 degree. When dipole is placed anti-parallel to the electric field, what happens? So when dipole is placed parallel to the electric field, torque is 0, work done is 0, potential energy is minimum, that is minus PE. When dipole is placed perpendicular to electric field, torque is maximum, PE, work is PE, potential energy is 0. When dipole is placed anti-parallel to the electric field, torque is 0, work done is maximum 2 PE and potential energy is maximum, that is PE, right? ಇಲ್ಲಿ work done 0, ಇಲ್ಲಿ work done PE, ಇಲ್ಲಿ work done 2 PE. ಇಲ್ಲಿ potential energy minus PE minimum, ಇಲ್ಲಿ potential energy 0, ಇಲ್ಲಿ potential energy plus PE maximum, right? Okay, next we'll go for another concept now, that is electric flux. See, by definition, electric flux is given by pi is equal to E ds cos theta. This is by definition. The same electric flux by Gauss law is given by pi is equal to Q by epsilon naught, right? Okay, ಇಲ್ಲಿ ನೋಡ್ರಿ E ds cos theta ಅಂತ ತಗೊಂಡ್ರೆ, here theta is the angle between area vector and the magnetic field, ಅಥವಾ normal to the surface area ಅಂತ ಏನಂತಾರೆ, ಆ area vector ಮತ್ತು area vector and electric field ಈ ಎರಡು ನಡುವಿನ angle ಇದೆ theta. So ಇಲ್ಲಿ ನೋಡ್ರಿ, here the surface area is held like this, electric field lines are like this, right? It means the surface area is held perpendicular to the direction of electric field. Surface area is held perpendicular to the direction of electric field. So area and electric field both are perpendicular to each other. But area vector, how will be the area vector? This is surface area and area vector is perpendicular. However you take, if you hold area like this, area vector will be like this. If you hold area like this, area vector will be like this. If you hold like this, it will be like this. If you hold like this, it will be like this. So for surface area, the area vector will always be perpendicular. That is perpendicular. So ille angle ನೀವು area vector ಮತ್ತು electric field ನಡುವಿನ ತಗೋಬೇಕು. When area is perpendicular to electric field, when area is perpendicular to electric field, area vector will be parallel to electric field. So theta is equal to 0 degree. So ನಿಮಗೆ question ಒಳಗೆ area is held perpendicular to electric field ಅಂದಮೇಲೆ ನೀವು theta is equal to 90 ತಗೋಬಾರದು. ನೀವು theta is equal to 0 ತಗೋಬೇಕು. So in case of electric flux ಏನ್ ಮಾಡ್ರಿ, ಅವ್ರಿ area perpendicular to field ಅಂತಂದ್ರೆ ನೀವು 0 ತಗೊಳ್ರಿ. Area parallel to field ಅಂದ್ರೆ ನೀವು 90 degree ತಗೊಳ್ರಿ. ರಿವರ್ಸ್ ತಗೋರಿ ಫ್ಲಕ್ಸ್ ಕೇಸ್ ಒಳಗೆ ಮಾತ್ರ. ರೈಟ್? Okay, ಇಲ್ಲಿ ನೋಡ್ರಿ, area is held parallel to electric field, but area vector is perpendicular to electric field. So theta we have taken it as 90 degree. Flux will be minimum. Here flux will be maximum. Flux will be maximum when area is held perpendicular to the electric field. Flux will be minimum when area is held parallel to the electric field. Right? Next note. By Gauss law, again flux is given by Q by epsilon naught. So note, for example, if this is a sphere A and there are two charges in this Q1 and Q2, on the plus Q1 other, on the minus Q2 ದಂತ ಇಟ್ಕೋರಿ. So flux of surface A will be equal to Q1 minus Q2 divided by epsilon naught. Right? Suppose ಇದು plus ಇತ್ತಪ್ಪ ಅಂದ್ರೆ ಇದು ನೀವು plus ಅಂತ ತಗೋಬಹುದು. Okay, next if I take one more surface called as B and there is a charge called as Q3 here. ನೋಡ್ರಿ, flux of B will be Q1 plus Q2 plus Q3, Q1 plus Q2 plus Q3 divided by epsilon naught. If there is one more charge here called as Q4, it is not included in the flux of A also and flux of B also. So ನೀವು ಏನು ಮಾಡಬೇಕು, only the enclosed charges ನೀವು ತಗೋಬೇಕು. ನೋಡ್ರಿ, A surface ಅಲ್ಲಿ flux ಬರಿಬೇಕಾದ್ರೆ you took only Q1 and Q2, you didn't take Q3, you didn't take Q4 because these both charges are outside that surface A, sphere A. So B flux ಬರಿಬೇಕಾದ್ರೆ Q1, Q2, Q3 ಮೂರು ತಗೊಂಡಿದ್ರಿ, Q4 ಬಿಟ್ಟಿದ್ರಿ because it is outside. So consider the charges which are inside that surface, that will give the flux. Okay, next note. Outward flux is taken positive, inward flux is taken negative. Positive charge ಒಳಗಡೆ ಇತ್ತಪ್ಪ ಅಂದ್ರೆ ಅದರ flux outwards ಇರ್ತದ್ರಿ, which is positive. Negative charge ಒಳಗಡೆ ಇತ್ತಪ್ಪ ಅಂದ್ರೆ ಅದರ flux inwards ಇರ್ತದ್ರಿ, which is negative. Okay, one more important concept is here, flux of cube. See, this is the cube and we have kept a charge at the center of the cube. So how much will be the flux of that cube now? Q by epsilon naught. How many faces are there for that cube? 6 faces are there. So flux of each face of the cube will be equal to, each face of the cube will be equal to Q by 6 epsilon naught. Andre idenne divided by 6 ಮಾಡಬೇಕು ನೀವು. Q by 6 epsilon naught. Flux of each face of the cube. ಈಗ ಇಲ್ಲಿ ನೋಡ್ರಿ, we have having one cube. ಆಮೇಲೆ we have kept the charge at the center of the one face of the cube. ಇಲ್ಲೇ at the center of the cube, ಇಲ್ಲೇ at the center of one face of the cube. Right? So here we have kept the charge at the center of the cube. It is Q by epsilon naught. Here we have kept the charge at one face at the center of the one face of the cube. So ಈ ತರ ಇದ್ದಾಗ ಈ ಚಾರ್ಜ್ ನ ಎನ್ಕ್ಲೋಸ್ ಮಾಡ್ಲಿಕ್ಕೆ ನೀವು ಇಲ್ಲಿ ಮತ್ತೊಂದು ಕ್ಯೂಬ್ ಅನ್ನು ತಗೋಬೇಕಾಗ್ತದ್ರಿ. You will have to take one more cube, then only that charge will get completely enclosed inside. ಆ ಚಾರ್ಜ್ ಈಗ ನಮಗೆ ಒಳಗಡೆ ಹೋದಂಗ ಆಗ್ತದ್ರಿ. ಸೊ ಈಗ ಈ ಚಾರ್ಜ್ ಅನ್ನು ಕವರ್ ಮಾಡ್ಕೊಳ್ಳಿಕ್ಕೆ ನಮಗೆ ಎರಡು ಕ್ಯೂಬ್ ಬೇಕಾದ್ರಿ. That's why the flux of one cube will be equal to Q by 2 epsilon naught. Q by 2 epsilon naught, because there is the requirement of two cubes to cover that charge. Okay, come here. The charge is placed at one corner of the cube. So to cover this charge, we require 8 cubes now. Namak 8 cubes beku, right? That's why flux of each cube will be equal to Q by 8 epsilon naught. Q by 8 epsilon naught. And there are 3 faces which are in touch with this charge now. Either face, backside face, and side face, these are in touch with that charge. There are 3 faces which are not in touch with the charge. This one, and this one, front side. These 3 faces, they are not in touch with that charge. So these opposite faces will be having this much amount of flux. Q by 24 epsilon naught. 3, right? So this into 3 madkontivi, Q by 24 epsilon naught. Okay, what if the charge is placed here? Ignore it. If there is a cube like this, and if I have placed a charge at one edge of the cube, how much will be the flux of this cube? So you should think that this charge and enclose madkolikke, to enclose this charge, how many number of cubes we require? We require 4 cubes here, right? One beside this cube, cube side, amali cube melgade 2 bekri. So 4. That's why the flux of one cube will be equal to Q divided by 4 epsilon naught. Q divided by 4 epsilon naught. Istu flux itiradu bartade, right? That is all about the flux. Okay, so that's all about the concepts of electric charges and field. So we have covered almost all the formulas, all the concepts and all the shortcuts in this chapter, right? Dear students, if you like the content of this channel, please don't forget to subscribe the channel and please share the video, share the channel with your friends. ಈಗ ನೋಡ್ರಿ ನಾ ಈಗ ಇದು ರ್ಯಾಪಿಡ್ ರಿವಿಷನ್ ಕೋರ್ಸ್ ಏನ್ ಮಾಡತ್ತೀನಲ್ಲ, I will cover all second PUC chapters in this, but ನೋಡ್ರಿ every day one video probably will not be possible for me. For 2 days one at least I can put, right? So as much as possible I will cover all the chapters. See, if you want, I can do it like this also. One chapter from first half, ಅಂದ್ರೆ first 8 chapters ಅದ ಏನದಾವ, ಆ first half ದಾಗಿಂದ one chapter, second half ದಾಗಿಂದ one chapter, ಮತ್ತು first half ದಾಗಿಂದ second chapter, second half ದಾಗಿಂದ second chapter, third, fourth, like this I can do. Otherwise, if you want serially, I will go 1, 2, 3, 4, 5, 6, so on like this, right? ಈ ತರ ನಾ ಹೋಗ್ತೀನಿ. See, ಈಗ ನಾ ಇದ್ರೊಳಗೆ ಈ series of videos ಒಳಗೆ I will just cover the concepts and formulas like this, so it will get revised for you rapidly, instantly. ಆಮೇಲೆ ಅದ್ರ ಮ್ಯಾಗಿಂದ MCQs ನಿಮ್ಗೆ ಏನಾದ್ರು ಬೇಕಾದ್ರೆ ನಿಮ್ಮ ಹತ್ರ ಯಾವ್ದು ಬುಕ್ ಅದ ಅದನ್ನ ಸಾಲ್ವ್ ಮಾಡ್ರಿ, ಇವು ಫಾರ್ಮುಲಾಸ್ಗಳನ್ನ ಅಪ್ಲೈ ಮಾಡಿ ಇನ್ಸ್ಟೆಡ್ ಆಫ್ ಟ್ರೈಂಗ್ ದ ನ್ಯೂ ಬುಕ್. ಅದರ್ವೈಸ್ ಇಫ್ ಯು ವಾಂಟ್ ಅನ್ ಎಕ್ಸರ್ಸೈಸ್ ಕ್ವೆಶನ್, ಒಂದು 20-25 ಕ್ವೆಶನ್ಸ್ ಆನ್ ಈ ಚಾಪ್ಟರ್ ನಿಮ್ಗೆ ಬೇಕಿತ್ತಪ್ಪ ಅಂತಂದ್ರೆ ಇವೆಲ್ಲ ಕಾನ್ಸೆಪ್ಟ್ಸ್ ಮೇಲೆ you just put a comment in the comment box. I will prepare a PDF on that and I will attach it, a drive link I will put in the description box. So ಇವತ್ತು ನೀವು ಕಮೆಂಟ್ ಹಾಕಿದ್ರೆ ನಾಳೆ ಅಥವಾ ನಾಡಿದ್ದು ನಾನು ಆ ಡಿಸ್ಕ್ರಿಪ್ಷನ್ ಬಾಕ್ಸ್ ಓಪನ್ ಮಾಡಿ ನೋಡ್ರಿ, ಅಲ್ಲಿ ನಾನು ನಿಮಗೆ ಲಿಂಕ್ ಕೊಟ್ಟಿರ್ತೀನಿ, right? So if you need anything else, please put a comment in the comment box and please share your view, your opinion on this series so that I can continue this series and I can help you throughout this KCET journey, right? Don't waste the time. There are very less number of days left to you. So please keep studying and do your KCET also good, right? Thank you so much. Please keep watching and supporting the channel. Thank you.